In this lecture, we will study bidirectional shift register, a very important topic. Before actually going to the circuit for the bidirectional shift register, let us take a 2-bit number. Let us take a 2-bit number 1 1, and the decimal equivalent for 1 1 is 3, we already know. And if I write down the weight for the position, then it should be 2 to the power 0, then we have 2 to the power 1, and then we have 2 to the power 2. This is 1, 2 and 4. These are the weight for the positions. And what if I shift this 1 1 to the left? I want to shift 1 1 to the left, so let's do it. This is 1 1 and a 0. We have shifted this 1 1 to the left. And now what we have in this case, if this is the binary, then the decimal equivalent is 6. Okay, 110 is 6 in decimal. So we had 3 earlier, and now by shifting the bits to the left we have 6. So we can say that we have multiplied the number by 2. We have multiplied the number by 2 and we have 6 now. So this is what we will have when we shift the bit to the left. Now what if I shift this bit to the right? So let's shift it to the right, and we again have a 110. So we had 6 and now we have 3. So what we have done, we have divided it by 2. So it is a very clear thing to know that when you shift the bit to the left, you are going to multiply that bit by 2, and when you shift the bit to the right, you are going to divide that bit by 2. Now if you want to divide and multiply the bits by using the shift register, you have to design your shift register in a way that it works in the both direction. By both direction I mean it must have the serial left shift mode as well as the serial right shift mode. That's why we call it bidirectional, because it is operational in both the direction. If you want to shift the bits to the left, you can do it, and if you want to shift the bit to the right, you can also do it. That's why it is bidirectional shift register. Now we will move to the circuit and let's see how we can have the bidirectional shift register. I have used the 4 flip-flops, flip-flop number 3, flip-flop number 2, flip-flop number 1 and flip-flop number 0. These are the 4 flip-flops, and you can see a combinational circuit is there, and the mode control input capital M is also used. And when we have capital M, the mode control input, equals to 1, we have the shift right operation. Let me write it down. We have the shift right operation. So let's see how it works when M is equal to 1. When M is equal to 1, here we have 0 and here we have 1, and you can see that M complement, that is 0 now, is acting as one of the input to the AND gate number 2, 4, 6 and 8, and that's why 2, 4, 6 and 8 are disabled, because one of the input is equal to 0. So we have 0 as the output for 2, 4, 6 and 8. Whereas in AND gate number 1, 3, 5 and 7, we have one of the input as 1. So simply we have the output as DR. For the gate number 1, DR represents the serial shift right input, whereas DL represents serial shift left input. And the AND gate number 1 will have output equal to DR. And finally, we have the output of this combinational circuit equal to DR, because DR or 0 is equal to DR. And in the same way, the output here will be equal to Q3. Because you can see Q3 is connected to AND gate number 3, and here we have Q3, that's why Q3 or 0 is equal to Q3. And in the same way we have Q2 here, Q1 here. Fine. So you can simply see that the data is shifting to the right. The data is first stored in the flip-flop number 3 for the first clock pulse, then it is transferred to flip-flop number 2 for the next clock pulse. In the same way, for the coming 2 clock pulses, it will be transferred to flip-flop number 1 and then flip-flop number 0. So it is shifting to the right like this. That's why we call it as shift right operation when M is equal to 1. In the same way, when capital M is equal to 0, we have shift left operation. You can easily analyze it by switching the input. Okay, let me do it quickly. Now we have m equals to 0. Therefore, here we have 0 and m complement will be now 1. So the AND gate number 2, 4, 6 and 8 will be operational, whereas the AND gate number 1, 3, 5 and 7 will be disabled. So let's see what we have in that case. DL is connected to AND gate number 8 and hence the output will be DL because the input is 1 and 1 and DL is equal to DL. So we have DL here, and finally the output here will be DL because the other input is equal to 0. So DL, the serial shift left input, is now stored in the flip-flop number 0. The output of this flip-flop Q0 is acting as one of the input to the AND gate number 6, and hence here we have Q0, and now Q0 will act as the input for this flip-flop. In the same way, here we have Q1 and here we have Q2. So you can clearly see that the data is shifting in the left. First we have the data DL stored in this flip-flop, then the output of this flip-flop is connected to the input of this flip-flop by the means of this combinational circuit. So the data stored here will now shifted to the flip-flop number 1, and again the output of the flip-flop number 1, Q1, is connected to the flip-flop number 2. Hence the data stored in this flip-flop will be shifted to the flip-flop number 2. In the same way, the data will shift to the last flip-flop, that is flip-flop number 3. So this is how we achieve the shift left operation, and you very well know that in D flip-flop we just store the data. When the input D is equal to 1, the next state is equal to 1, and if the input D is equal to 0, the next state is equal to 0. So whatever be the input here, it is stored in the flip-flop, and thus the data that we are entering will get stored in the first flip-flop and then to the next, and in the same way it will shift to the left when m is equal to 0, and it will shift to the right when m is equal to 1. So this is how the bidirectional shift register work, and we can perform the multiplication and division by using this shift register, and it is a very important shift register, and the chances for this question to come in your exam is very high. It is very easy. You just need to know two things. The first thing is the logic gates, how this gate works, how the output is obtained depending upon the input, and a little bit about the D flip-flop, how the data is stored in the D flip-flop, and also a little bit about the register. So this is all that you need to know to understand this topic.